Hi everyone, my name is Brian McInerney. I'm the hydrologist here at the National Weather Service Forecast Office in Salt Lake City. This is a quick debrief on the little Cottonwood debris flow that occurred on August 9th. So, if you're not familiar with Little Cottonwood Canyon, this is just a quick reference to see where it is. It's in Salt Lake County, it's in the Wasatch Range. Alta, Snowbird are at the very top, two famous ski resorts. And you can see that area with Twin Peaks, O'Sullivan Peak, Dromedary Peak. That area, right about the central part of the canyon, received a lot of thunderstorms and produced a debris flow down onto the canyon. It's steep, it's rocky, and the road is in an unfortunate position when you look at this. When you look at antecedent precipitation, roughly the week before, from the 1st, the 3rd, the 5th, the 6th, the 7th, and the 8th, we had precip on every day. And this is Alta Collins Co-op Station. On the first, it was 4/10, and then the third had 2.11. The fifth was a hundredth. The sixth was 24 hundredths. The seventh, a hundredth, and the eighth was 200ths. And so we had precip throughout the entire time. My feeling is, though, this is a pretty steep walled canyon with not a lot of holding capacity. Things drain out of here pretty quick, but nonetheless, we did have precip during this time. When you look at the return interval, how often, when you look at the two observations that we have, how often does this happen, roughly statistically? And what we'll do is we'll look at 2 points. 1.12, and this was observed in Sandy, and this occurred in roughly about 40 minutes. And then the radar, and that's this guy right here, the radar showed 3.15 inches fell in about an hour's time over this. And when you look at the return interval, in a 30-minute time, in our case it was 40 minutes and it was 1.08, but this is the closest I could get. It's roughly the average recurrence interval in years is 25 years, 1 out of 25. Pretty significant. But when you look at what the radar showed, 3.15 inches of rainfall in 60 minutes, that occurs at this location every 500 years. Now, the question is, what observation do we rely on? My feeling is the first one, 1.08, was recorded in Sandy. The storm moved up the canyon. The intensity increased because also you have to look at what happened. This was massive. My feeling is it's closer to the radar estimate, but radar can be biased by hail and that kind of thing. But we really didn't see any hail in this event. It was a low centroid, deep, warm cloud layer, and it produced a phenomenal amount of rain because of the debris. So we're probably closer to the radar, but I don't think we'll know for sure. So when you look at the radar reflectivity, this is going to go pretty quick, and this is 723 to 753 that evening on August 9th. And this is what we saw at the National Weather Service. You can see that red area moving in to Little Cottonwood, and it's in that square area. If you look at Alta and the road coming up from the valley, that'll give you some reference where you are. The box is centered right over the ridge on the north end of the canyon. And you can see as it moves through, there's two pulses. The first one goes through at very high reflectivity rates, and then there's a second pulse right there. And I think it's the second pulse that really kicked this off and produced the debris that we had. If you look at this in 3 dimensions, and we'll start with 723 and we'll go slow. I think the thing to consider is the image shows the elevation of the storm. And anytime you have a deep, warm cloud layer at very low elevations, and it doesn't get vertical, it doesn't go up to 20,000 feet or 30,000 feet. And what we're looking at is that red area. It indicates there's shallow updrafts. The storm isn't going to build vertically. There's limited shear, so what you have is going to stay right there. And then we have very high relative humidity through that deep layer. And what that does is produces what's called warm rain processes, where you have drops of rain that are quite large and they interact with each other. They kind of hit each other and make bigger drops, and it's a very efficient rainer if it stays low. And it's the centroid of the storm is really quite low. So here's 723. Here's 728. Again, very low, right over the canyon. 733, and we're looking kind of at an angle. You can see the west and the south boundaries on this, and we're kind of looking and from the corner looking northeast onto this. If you were down in Sandy, that's how we're looking at this storm, how I oriented this. Then if you go to 738, again, that low centroid of the storm is producing rain at a very heavy rate. 743, it's slowed down just a bit, and then it picks up a little bit more at 748. Again, we're not building the storm vertically. We have warm rain processes in effect. It's low centroid. It's incredibly wet in there. And then we move to 753. The storm is starting to fall apart, and then move on. So there you have it. This is Brian McInerney. Glenn Merrill is a good reference for this type of thing. He's a meteorologist at the National Weather Service. I got a lot of the information from work that he has done and some of the other meteorologists at the Weather Service. But if you need anything, you can always give me a call, 801-971-2033, or Glenn. He's also somebody to talk to about this. But nonetheless, it was a very intense rain event in a very short period of time and produced a monster of a debris flow. And we'll go from there. Thank you.